There are many different forecasting methods. You'll learn about them by reading the assigned pages in the textbook. Here I focus on introducing the time series forecasting. A time series is a collection of data recorded over a period of time, weekly, monthly, quarterly, or yearly. It can be used by management to make current decisions and plans based on long-term forecasting. Because we usually assume past pattern will continue into the future. Therefore, the forecast is necessary to have the raw materials, production facilities, and staff to meet the projected demand. Before we start, I have to mention that this system of forecasting does not explain the reason for the changes of the data. It just says that the series of numbers to be projected changes as time goes by. When data are collected over a number of periods in the past, they usually exhibit four different characteristics. First one, trend. That is the direction or movement of the data over a relatively long period of time, either upward or downward. Here are three examples of a trend. This chart shows the number of employees at the Home Depot. You can see this number has increased rapidly over 14 years from 1993 to 2006. This chart shows the number of the emergency medical service calls in Horry County, South Carolina since 1989. The number of calls for emergency medical services has increased nearly 3.5 times from 1989 to 2008. This chart shows a steady increase of the number of the manufactured homes shipped in the United States from the 1990 to 1996. They remain about the same until 1999 when the numbers began to decline. The second characteristic is the cyclical fluctuation, also called the cyclical variation. The rise and falls of a time series over a period longer than 1 year. This chart shows the annual sales of the batteries sold by the national battery retailers from 1989 through 2008. The cyclical nature of the business is highlighted. There are periods of the recovery, followed by prosperity, then recession, and finally the cycle bottoms out with depression. The third component of the time series is the seasonal variation. Many sales production and other theories fluctuate with the seasons. For example, toy sales tend to rise briefly before Christmas. The unit of the time reported is either quarterly or monthly. This chart shows the quarterly sales in millions of dollars of the Herschel sporting goods. The Chicago area of this company specializes in selling baseball and softball equipment to high schools, college, and young leagues. There is a distinct seasonal pattern to its business. Most sales are in the first and second quarter of the year when schools and organizations are purchasing equipment for upcoming season. The fourth component is irregular or random, such as fluctuations caused by earthquake, war, or strike. Basically, our goal here is to remove all the fluctuations, smooth a time series to see its trend. For example, this chart shows from year 2001 to 2009, the actual sales data are along this blue curve. Our goal is using certain method to smooth out these fluctuations and find out the trend, this red line. Once we find out the red line, we can predict the future sales, such as the sales in the year 2001 or 2012 or 2015, 2020, something like that. Then the basic method we're going to use to smooth out all the fluctuations is the moving average method. The data here shows the sales for some company from year 2001 to 2009. If we select them, select this data, then click Insert, then select Scatters. Select these scatters with straight lines. The chart pump up. You can see here. You can see the sales fluctuate over the years. So our goal is smoothing these fluctuations out to see its trend. We can also see the cycle here repeat itself about every 3 years. So we're gonna use 3-year moving average. First, we're gonna determine the 3-year moving total. Type the 3-year moving total in this cell, and then we find out. Then we need to sum up the sales from the first 3 years. We're gonna position that in the middle. This cell between these 3 years in the middle. Types in sum first 3 years. Then here we end up the second 3 years because this is the 3-year moving total. So the total sales from the second 3 years. Then the third, sum up the third 3 years. We actually can pulling down this button to copy the formula all the way down. Okay, here we go. We get the 3-year moving total, and the next step we find out the 3-year moving average. 3-year moving average. Okay, by divide each 3-year moving total by 3. So again, we can copy this formula all the way down by pulling down this button. So now we get the 3-year moving average. We can go even further to find out the centered moving average by finding the average number of the two moving average. We find this by finding the average number of those two moving average. So equal to average these two. Then copy the formula all the way down here. Okay, now so through these 3 steps, we did a perfect moving average. This group of the data is the result of the application of the moving average. We can see this by a chart. First, let's select the original group of data, and at the same time copy this part, then insert scatters. Okay, here you go. You can see this. So this red line is the trend after we smoothing out the fluctuations. Once we smooth out the fluctuations, we get the trend as we just seen in the chart. We usually get 3 different possibilities. The trend is a straight line or closer to a straight line. The trend is an exponential line, look like this, or the trend is a quadratic curve. But in this class, I only focus on when the trend is a straight line or closer to a straight line. We call it a linear trend. The equation for the linear trend is y hat equal to a plus bt. Y hat is a projected, or we say estimated, value of the Y variable for selected value of the T. T is any value of the time coded. And so we give the different period of time a code, a time code. We will give the 1 to the first period of time, 2 to the second period of time, 3 to the third period of time. For example, if our data starting with the 1989, so then the 1989 would be 1, then 1990 will be 2, and the 1991 will be 3. A is a y-intercept. That's the estimated value of y when the time is 0. The B is the slope of the line. It's the coefficient of the independent variable of the t here, time. Okay, now let's go back to our Excel sheets. So I'm gonna show you how we're gonna use our data to find out the equation. More specifically, how we find out the value for A and B. Once we find out the value for A and B, then we can get the value for any Y based on the given time. So now we're gonna find out the equation for this group of the data, the trend that we just found out. So let's put the time code here for it. Time code. Okay, that's the T. As I said, the first here gonna be the 1, 2, 3. You actually can select all of them, bring down the little button, so for 6 years. Okay, now we're gonna do the same thing you already did in the last chapter. Then we click data analysis, select regression, click OK. Input a Y range, that would be our, for the input Y range, that would be the value from the centered moving average. Then input the X range is value for the T, the time code. Then new worksheet, click OK. Here's the result. Here's the result. So we get the coefficient, the ANOVA table. Coefficient in the intercept, that's the value for A, is 11.1111. And the X variable, that's a T, the coefficient for the T is minus 0.23. So now we can write out the equation for this trend is y equal to 11.11 minus 0.23 times t, the time. Let's say we will try to find out the sales for 2010. Okay, that's gonna be the 8th year. So what's the estimated the value y hat for the 8th year? That's gonna be equal to A 11.1111 minus 0.23 times 8. So the estimated or the forecasted sales for year 2010 would be 9.27. So now hopefully you understand the basic logic behind this whole process. Let's check how we smooth the data which are collected seasonally to get the trend and do the forecasting. It's kind of a little bit complicated. Here are the sales data for the International Toy Company. It was collected from the 2004 to 2009 seasonally. we will eliminate all the seasonality and calculate the trend, and then determine the equation for the trend data, and then find out the projected sales in the future. So first, let's put in the time code. That's 1 for the first period of time, 2 for the second, 3 for the third, 4 for the fourth, and you can actually select this and copy this, putting it up, down. Then let's find out the value for the moving total, moving average, and standard moving average. Get a moving total by sum up the sales from the first 4 seasons. I suppose this behind the spring, start with spring, something kind of in the center. Here, then the second 4 seasons. We can actually copy this. Then moving average is each value from the moving total divided by 4. Bring it on down. Then we get the standard moving average by average to moving average. Bring it down. Next step, we're gonna use the sales from this column divided by the centered moving average to get a specific seasonal index for each period of time. So this one equal to sales divided by standard moving average. Then bring this, copy the formulas all the way down here. Okay. Each specific seasonal index in this column represents the average sales for a period of several years. For example, the index of 1.17 in the summer of the 2004, that indicates that typically sales for this summer are 17.9% above the average season. The index of the 0.77 in the winter 2005, that shows the sales for the winter here are typically 23% below the average sales. Next step, we're gonna use the average. Next, in order to eliminate the random component, that's also the irregular component, we're gonna to calculate the average of SSR. We call that typical seasonal index. So how do we do that? That is, we're gonna find out the average, the mean number for all the winter specific seasonal index, and we find out the mean number of all the specific spring index, and we're gonna find out the mean number, the average number of all the summer index, and the mean for all the fall specific fall index. So let's try it here. It's equal to, so the typical seasonal index for the winter gonna be the average value of the winter, the specific seasonal index for the winter over the years. Winter, the next winter is here, and this one, this one. Press the enter. So we get the typical seasonal index for winter. The next one is spring. So spring's here. Spring. Spring. Then the typical seasonal index for the summer gonna be started with this one. It's equal to average. Oh, cannot say that right now. So it's H4. This one and this one. It's gonna be average. For the fall, gonna be H. Here, H13. And it's one. Next step, we need to divide each individual typical seasonal index by the average typical seasonal index to get the adjusted seasonal index. How do we do that? We take each one divided by average. Check the formula here. If I can put the dollar sign here in front of enter, then I can copy the formulas down. Okay, now this one equal to, and here is the spring of the 2005 equal to the adjusted seasonal index for the spring of the 2004 equal to this one. You have to type this in. Then you can select all of them and bring down the button to copy the formulas. Now we have, say, exactly the same adjusted seasonal index for winter and the same one for the spring for the every year, the same one for the summer for every year is the one, and the same one for the fall for the every year. Now we are at the last step. In order to remove all the fluctuations to see the trend, it is a seasonal index. Sales divided by the adjusted seasonal index equal to this one. So put down this button to copy all the formulas. Okay, here are the data for the trend. Now we can use the same method. Go to the data, select the regression, then put the sales deseasonalized into the while range. Then we put the time code into the X range. Then click OK. Here we go. So the equation for the trend will be the sales equal to A plus B times T. A is this intercept 8.037, and B is the coefficient for the X variable, that is the time code. The forecasted sales for the future. Let's assume we try to find out the forecasted sales for the 2010 and in the winter. For this one, the time code is 25. Okay. So that's gonna be equal to A plus B times time code. Okay. So the value for A is actually in the sheet 5. That's the ANOVA analysis result is here. So A is here, equal to A plus, okay, you can see it here. So A plus B times the time code. Back to the sheet 1. The time code is 25. Okay. Here we go. That's the result, 10.507 million US dollars. We can also, because that's the estimated value along the trend line, we can also find out the seasonalized estimated value for that winter, equal to this one times the adjusted seasonal index for winter, that is this one. We get a 8.037. So this one is the estimated sales value for the winter 2010. We are done now. So we basically learned the moving average method and use it to remove all the fluctuations and get the data for the trend. And then we use data analysis to figure out the equation for that trend. Then, based on that equation, we can predict the values for the future, the values of the sales or production cost, or any data we need for the future. And also, if there's a seasonalized data, we can also find the specifically seasonalized value for that one. Okay, again, if you have any questions, please send me email and we can set up an online office hour.